All right, pre-calc, let's talk polynomials. That is going to be pretty much the sole focus of this unit for us. And so I think today is as good a day as ever to get us a little bit of an intro to polynomials and a little bit of a review into different operations that we can do with polynomials. So when we're talking about a polynomial, like what we mean, if we were to break down this word a little bit, poly means like many, and then nomial, more or less it means like terms or names or whatever you want to call it, many things, many terms. And like that's literally exactly what a polynomial is. If we look at a couple examples here on the right, which I would go ahead and like start copying down your notes, we'll use these to reference a few of our vocab words with polynomials. But like we know a polynomial, it has many terms that are being added and subtracted together. They can have different coefficients, different exponents, right? But the idea that there are two or more terms that are being added or subtracted together is what makes up a polynomial. A polynomial can come in two forms primarily that we are going to work with, and that is when a polynomial is in standard form, like we see here in green, and a polynomial that is in factored form. The key with standard form is that you'll notice like everything is all multiplied out, all like terms have been combined, and the key is that your terms are in a specific order, and that order has to do with the exponent of the variable. And that order is always, so like in order, and that is like our terms. Our terms are in order based on exponent. So based on our exponent. And it's going to go from the biggest exponent to the smallest. So from biggest to smallest. When we are looking at this example here in green, we see that the biggest exponent on these variables is 4. And so that is the term that we put first, 3x to the 4th. The next biggest exponent is 3. That is the term that comes next, so on and so forth, until we get to our constant at the end here, negative 15. It doesn't have a variable with an exponent, or I guess if you want to think about it, it's like x to the 0 there, right? X to the 0 is just 1. We've talked about that. All these terms are in order from biggest to smallest exponent. And that is when you know that something's in standard form. When we were talking about something in factored form, whoops, you can see here that you have things that are being multiplied together, different terms, and when you're looking at each of these x's, this isn't 100% going to be true all the time, but something you notice here, and that will be true a lot of the times, is that our x values have an exponent of 1, of 1, of 1. And this is a good clue for us that tells us, hey, like, is this polynomial fully factored? If I see a bunch of x's with exponents of 1, probably fully factored here. All right, and so those are the two primary forms that we will deal with polynomials. And for the most part, our goal is to actually solve polynomials this unit, which means we're trying to get x equals. And that means part of the process is trying to go from standard form to factored form. That is part of our process. And we'll talk more about that later. But that's why both of these forms really matter to us. Now let's go ahead and talk about a vocab word having to do with polynomials, and that is degree. When I'm talking about degree, what I am talking about is the biggest exponent I see when my polynomial is in standard form. So under the standard form column for degree, I'm going to say, hey, that's just going to be whatever my highest exponent is. So highest exponent. If I'm looking at my polynomial, right, we already talked about the fact that if our polynomial is in standard form, our highest exponent should be a part of the first term. And as we double check just to make sure, yes, 4 is the biggest exponent, that is going to be our degree. And so I would say the degree of this polynomial in green is 4. The degree is 4. And that is going to matter for us later this week. So that's great that we're talking about it now. When we're we can still determine the degree of a polynomial even when it's in factored form. It's just a little bit more complex. And the way we're going to do that is just by adding our exponents, add exponents. And when we're adding our exponents, I think it's really helpful to go ahead and if I see any factor that has an exponent that's not 1, like for example this x plus 2 factor that I have is to the second power, I like to go ahead and write that out as like x plus 2 times x plus 2. It's going to make adding my exponents a little bit easier. Maybe not for this example specifically, but there will be more complicated examples where writing this out as the factor two times is going to make it a lot easier for you. And so if I am adding my exponents together, well, I have x to the first plus x to the first, that's 2, 3, 4. My degree for this polynomial is also going to be 4. Let's go ahead and talk about a leading coefficient. And this is actually something that makes a lot more sense now that we've talked about our degree. And so you can see on your notes already, I have this filled out for you. Let's actually talk about what it means. So when I'm talking about the leading coefficient of a polynomial that's in standard form, it's going to be the number in front of the variable with the highest exponent, which what we just said, our highest exponent is our degree. And so we are getting our degree, which is 4, from this term, 3x to the 4th. The leading coefficient is just this coefficient, this number, out front of that term. And so my leading coefficient for this first example is 3. It's as simple as that. As long as we know our degree, we're looking at that term, and we're just picking out our coefficient. When our polynomial's in factored form, again, it's going to create a little more work on our end, but still very doable. And I highly recommend, again, that you have written out your polynomial as laid out as you possibly can be. This x plus 2 squared is written as x plus 2 times x plus 2, because what we're going to do to find the leading coefficient for a polynomial in factored form is to multiply all the coefficients together. And I think that's a lot easier to see when things are laid out a little bit like I have here. And so I'm just going to find all my coefficients. So I have 2 times 1 times 1 times 1 times 4. And that is going to get me, again, 2 times 1 times 1 times 1 times 4. Well, that's just going to be 2 times 4. And so my leading coefficient, if I were to multiply all these factors out, would be 8. And that's really nice for us, right? Because we don't actually have to multiply all of these factors together to get this polynomial in standard form. We can think smart and not have to do all that hard work. And we can still get to our end result, which is a leading coefficient of 8. Last thing I want to talk about, just a reminder of 2 terms that we have seen before. When my polynomial is in standard form, I do have terms. That's just how many things are being added or subtracted together. I have 1 term, 2, 3, 4, and even this constant, negative 15, that counts as a term for me. I have 5 terms for this polynomial. When I am talking about a polynomial in factored form, I'm again pretty obviously focused on factors. And this is where I want to look at everything laid out again. My polynomial here written in pink. Because even though x plus 2 is written here twice, those count as, each of those counts as a factor, even though it's the same factor. So I have 1 factor, 2 factor, 3 factor, and 4 factor, counting every single factor that has an x in it. This 2 is just a number. There is no x. Therefore, it is not considered a factor. So we have 4 factors in this polynomial. Something else I want to mention before we move on is that there are 2 different types of ways that we can actually describe a polynomial, to be more specific. And that is based on the number of terms it has. And you can see 3 examples. Monomial, that means it's a polynomial with just 1 term. Binomials with 2. Trinomials with 3 terms. I have examples of each. We've seen those before. We'll continue to use that vocabulary, but it is there and written out for you already. Another way we can describe a polynomial is based on its biggest exponent, which again we said is its degree. Sorry, I'm writing this with a highlighter, but our biggest exponent is the degree. And so when the degree is 1, it's a linear function. When it's 2, it's quadratic. 3, 4, 5. Again, this is written out for you because this is stuff we've seen before. I want to move on to some of our operations with polynomials.